back to my channel, and today we will together solve the LeetCode daily problem. And today's problem is related to the bit manipulation. And from my perspective, the bit manipulation is always like the hard question for sure. And so when you see, when you think that like for the bit manipulation, this is like the solution should be normally it should be like the ON by 32. So here the 32 is what is the 32? That is the number of the bits we use to represent a number. For example, like 3 in here will be like described by 32 bits using in our operating system. So this would be the always the time complexity for us. Okay, so I suggest to read all of the hints here. However, like I didn't read the hint and I've come up with the strategy by myself, and I think that it would be like, I hope that this one will be more easier for you to understand. Yeah, right. So let's go dig deep into the problem. So here like we are given the nums, and in here like I also have the numbers, and in the numbers in here we also have the bit representation for the number. So in here like how can we manage this problem? So let's say that in here we have the index as well. The index is 4, 3, 2, 1, and 0. This is the index, right? This is the index. This is our index. And then so somehow how can we manipulate these things? So normally when we used to keep the things like this is the most significant bit, and then it means that we normally use an array to retain the logic of the bit position for this kind of the problem. So here like let's say that this one is the most significant bit, right? And this one is the bit 31st, and so the also we have 32, and this one is like the bit 1, and this one is 0, right? Here is the bit position. Okay, so we can see that in here like I will initialize the value for these bit position. If that is start from 0, I will put that is -1. However, in here like that would be like the 1 in here, right? We need to do something, so I will put the index of the number in here. Okay, why? So you can see that, for example, like it is bad because like we can see that if we start from the last number and always the value or the answer is 1, so it means that there is no future value in here. So it suggests that somehow like we should start from here, and then somehow like from here we will get some kind of the formula or approach for our problem. So here let's say that here like we can see that we have 4, right? That is the current, so that is the index where the number, the bit position where the bit 1 appears. And then so somehow like in here we can see that what is the answer in here, that is the 1, right? So how can we come up with the answer? So you can see that in here we should get the max through the bit position in here. So what is the maximum value? That is the 4, right? Okay, so what is the value we have in here? And then so we need to use the max, and then we minus the current index, and then plus 1. Okay, so here that is the, okay, so I will rewrite it in the better format. So that is the max, right? And then we minus the current index, and then we plus 1, right? So that is what? That is the 4 minus 4 and plus 1. That is the 1, right? Let's say that this one is the correct value. So let's say we have the answer array. So we just put the 1 at the end. Okay. Okay, so for now we have already have something in here, but let's iterate into the next element. We will do the it backward like this, and then so let's see how it will be changed. So here, so we have the most significant bit is still the same, right? So that is the from here to here, from here to here, here to here, and here to here. Okay, so we have the most significant bit, which is like 31, 0 to 0, right? It's still the same, so nothing changed. That is -1. Okay, 30, same. minus 1. Okay, until we go to the 0 here, right? Something happens in here. In here we have two interesting cases. First one is from 1 to 0 and another one is from the 1 to 1. Okay, so how about the 1 to 0? In here like that is the bit number 1, right? So here like from 1 to 0, what should we do? We will keep the index here. We will keep this one as 4. Because of what? Because of we are trying to get the maximum value and the minimum size of the subarray. So it means that if this one is 0 and the future value is 1, I mean this one is the next value. So it means that somehow now it should make the combination with the future value, future number to maximize the return value, right? So it means that here like we should get we should retain the same number as before. Okay, so how in this case, like what if the 1 to 1? So here like because like we want to minimize the size of the array, right? And what if this bit have already been the value of 1? So it means that we don't need to consider the future value anymore. So what does this mean? This means that we should keep this value, keep this index from here, right? And here like we have 3. Okay, so for now, what is the maximum of this entire indexes? That would be 4, right? And what is the current index? Current index would be 3, and then we plus 1, and that would be 2. We add the 2 into our answer. Okay, okay, so we do one more example. So here there's still like 0 0, right? 0 0. Okay, so in here we have 0 to 1, right? And 1 to 0. What is our logic in here? That is the 31 still minus 1, right? 30 still minus 1 until we get 1. Okay, what is the 1 in here? Okay, 1 in here, 1 in here, 1. Index position 1th. The first position, right? And then because like it is the 1, so we will not get the future value. We will believe in the current value. So here like that would be 4. Sorry, that would be 2. 2, right? We will get this value. Okay, so for the 0, okay, for the 0, because we do not have the value in here, however we know that the nearest neighbor to have the value of 3, which is the with the value of 1, which is the 3, right? So we put the 3 in here. So what is the value in here? We have maximum value is what? That is a 3, right? And what is the current index? That is the 2. And then we plus 1, and then we put the 2 here. Okay, so you can try to do this to here and to here, and then finally you will get 3 and 3 to the answer. So you can try to go to like forward, but it will not work because like it cannot guarantee the linear time. So you can try and think about that. Okay, so for now we will together program this problem. Let's program this together. So firstly I will create the bit array, which is equal to the I will initialize all of the value for the things like, yeah, in here like for each number we have the 32 bits, and I will initialize that value by using the -1, and then I will like do this with the length of the nums, right? And then we have the answer array, which will store our final values. And so here like because I got the exception before, so I use the so my first exception is like I got this one. So when they are all of the 0 at the end, and so this is very difficult case, so I can consider this one as the corner case, so I solve it. Okay, so using one of the stated or the flag. Yeah, so for now I will iterate this one in the reverse mode of the range and for all of the numbers we have, and I will be the index, and then so I will go through all of the bits. So here like we have the bits, which is equal to the nums of I, and then I will shift it to the right, and then so shift by J, right? And then we get 1. Okay, so what if the bit equal to 1? And then we will update the bit of the array for the num I and the position J by the I, right? By the current index. And we will set the on 0 to the false, right? Okay, so here like we also need to keep the previous one. I mean the previous one will be, because like we have the transition state, right? And then we need to have somehow like we need to keep the previous state to make the comparison. Yeah, so yeah, I think that is like the transition. However, like I don't think that we need to keep this one. That is just the intuition, and then somehow like we can ignore this one, because like somehow in here we only change if the current one is 1. Otherwise we will keep it the same. We'll keep it the same, right? For example, like here we will keep all the things the same, so we can ignore the previous state. And if the on of the 0, and then so we just need to get the answer dot insert about the first position. Otherwise we, because like we need to for example, like if we find at least one bit position which is differ from 0, and then we are safely like not remove it. Otherwise it should be like on of the value as -1, and then we just need to put the 0 to the value of 1 there. This one would be like we always insert to the max of the bit array I, right? And then so here like we will minus I and plus 1 as expected, and we can return the answer. Okay, looks good. Okay, so I think that like my approach is not optimized, and then so somehow like you can use your knowledge and the coding techniques to improve the code further based on the idea, and I hope that you can like have more interesting way to solve this problem. Thank you so much for watching my video, and yeah, if you like and you want to encourage me to do more videos in the future, please give me a subscribe to see the more videos in the future. Thank you so much for watching my video, and see you next time.